A giant swarm of 1,000,000 ancient stars is sinking into its own core right now. Scientists thought only 5 stars were falling toward the center. Not 5, thousands. Deep inside a crowded sphere of light, gravity is tearing the entire cluster apart from the inside out. If you love exploring the strange secrets of the universe with real facts and zero clickbait, hit that subscribe button. By joining our community today, you will be among the first to discover what is really happening in deep space. Let us dive into the mystery together and see what the latest data reveals. To understand why this discovery sent shockwaves through the astronomy world, we have to start at the beginning. Imagine a giant ball of light packed with up to 1,000,000 stars all floating close together. Astronomers call these giant space cities globular star clusters. They are some of the oldest structures in the entire universe, with many forming over 12 billion years ago. To put that into perspective, our own planet Earth is about 4.5 billion years old. That means these star clusters were already ancient long before our world was even a cloud of dust. Most galaxies have these massive star clusters floating in a halo all around them. Our own galaxy, the Milky Way, has about 150 of these clusters orbiting around its center. They look like glowing snow globes drifting peacefully through the dark ocean of space. Because they have stayed together for billions of years, scientists believe they were stable and peaceful places. They thought the stars inside them had settled into a smooth and gentle dance that would last forever. The heavy stars stayed near the middle while the lighter stars drifted near the outer edges in total harmony. For decades, textbook science told us that star clusters were like eternal cosmic clocks. Researchers assumed that gravity held them together so well that nothing could ever disturb them. When telescopes first looked closely at clusters like Messier 15 or NGC 6397, everything seemed normal. The stars were packed tightly together, glowing brightly against the black background of space. Astronomers measured how fast the stars moved and calculated that the cluster had enough energy to stay stable. It was a neat and clean theory that gave scientists a comfortable feeling of order in the cosmos. However, the laws of physics hide a dark trick when you pack too many objects into a small space. Think about a crowded room where hundreds of people are constantly bumping into each other while walking around. When stars get extremely close together, they do not usually crash directly into one another. Instead, their gravitational pulls yank on each other every single time they pass nearby. During these endless close encounters, a strange exchange of energy takes place between the heavy stars and the light stars. The heavier stars lose a tiny bit of their speed and start sinking lower toward the center of the cluster. At the same time, the lighter stars gain speed and get kicked out toward the loose outer edges. Scientists call this process mass segregation, and it acts like a giant cosmic funnel. Over billions of years, all the heaviest objects in the cluster sink toward the middle like rocks falling to the bottom of a pond. As more heavy objects gather in the center, the gravity at the core becomes insanely strong. The core gets smaller, hotter, and denser as more mass gets pulled into a tiny central point. Astronomers knew this process existed on paper, but they thought it took so long that it would rarely finish. They expected the cluster to stay mostly intact, with just a slightly crowded center. Did you know that stars inside a cluster can exchange energy just like billiard balls colliding on a pool table? If this surprising fact about cosmic physics blew your mind, drop a quick like on the video and let me know in the comments below. Your support helps bring more real scientific discoveries to curious minds every day. When space telescopes like the Hubble Space Telescope turned their sharp cameras toward the cluster cores, the picture changed completely. Instead of finding a smooth and balanced center, scientists saw something that shocked them. The core of the cluster had collapsed into an unbelievably tight knot of matter. In a normal patch of space near our sun, the nearest neighboring star is about 4 light years away. That is roughly 24 trillion miles of empty space separating us from our closest neighbor. If you lived inside a normal part of the sky, you would only see a few bright stars scattered across the dark night. But inside the collapsed core of this star cluster, thousands of stars are crammed into a space smaller than 1 light year. If you stood on a planet inside that collapsed core, the sky would be so bright that night would never exist. The stars would shine like thousands of full moons, lighting up the ground with a blinding continuous glow. Yet behind that breathtaking beauty lies a terrifying environment ruled by chaotic gravitational forces. Stars are moving at crazy speeds, zooming past each other at over 100 kilometers every single second. That is fast enough to travel from New York to London in less than a minute. This discovery created a massive puzzle for the scientific community because the core was far too dense. According to the old computer models, the center should have pushed back against gravity using the energy of orbiting binary stars. Binary stars are 2 stars that orbit each other like a spinning pair of dumbbells. When a third star gets close to a binary pair, the pair can kick the third star away while pulling closer together. This kick releases energy into the core, acting like an oven that keeps the core warm and prevents total collapse. Astronomers expected these binary pairs to act as a natural heating system that stops the cluster from crushing itself. What they actually found in the real data was a complete collapse that went far beyond what heating could stop. The core had shrunk down to a fraction of its original size, becoming a gravity trap of unimaginable density. Scientists realized that the binary heating mechanism had failed, or had been completely overwhelmed by the sheer mass sinking inward. This gap between expectations and reality forced researchers to rethink everything they knew about how stars interact in tight spaces. It meant that star clusters were not peaceful, permanent cities, but ticking time bombs undergoing radical transformation. To make sense of this strange event, a team of researchers led by Columbia University began analyzing massive amounts of sky data. They used data from the European Space Agency's Gaia satellite, which has been mapping the positions and movements of over 1 billion stars. By tracking the exact speed and direction of individual stars in the cluster, they could construct a 3-dimensional map of the core. They also gathered infrared measurements from NASA's NEOWISE mission and sharp images from the W.M. Keck Observatory in Hawaii. Combining space telescope data with giant ground-based mirrors gave them the clearest view of a collapsed cluster ever captured. Have you ever wondered what it would look like if our own sun were trapped inside a crowded star cluster like this? Tell me your thoughts in the comments, and if you're enjoying this deep dive into real astronomy, make sure to subscribe to the channel right now. It takes just one click to stay connected with the most exciting discoveries in space exploration. Now let us look at the terrifying force hiding right at the very center of this collapsed cluster. When scientists first saw the extreme density at the heart of the collapsed cluster, they immediately suspected a massive culprit. For years, astronomers have been searching for a missing link in the black hole family tree. We know that small black holes form when a single massive star dies and collapses under its own weight. These stellar mass black holes are usually about 5 to 30 times heavier than our sun. On the other side of the scale, we have supermassive black holes sitting at the centers of giant galaxies. These monsters can be millions or even billions of times heavier than our sun. Logic dictates that something must exist in the middle, known as an intermediate mass black hole. Scientists predicted that a collapsed star cluster would be the absolute best place in the universe to find one. They believed that as stars sank into the dense core, they would smash together and merge into one super heavy object. Eventually, that super heavy star would collapse, leaving behind an intermediate mass black hole about 1,000 times heavier than the sun. This monster would then act as an anchor, pulling all the surrounding stars into a tight orbit around its invisible center. Astronomers pointed the Hubble Space Telescope right at the heart of the collapsed cluster NGC 6397 to confirm this theory. They expected to see the stars in the center orbiting around a single central point at extreme speeds. That telltale signature would prove that a medium-sized black hole was sitting quietly in the middle. The researchers carefully measured the motions of hundreds of stars near the center over several years of observation. Every computer calculation pointed toward a massive gravitational pull coming from the absolute center of the cluster. The team was ready to announce the long-awaited discovery of the missing intermediate black hole. Instead of finding one single black hole sitting in the center, the data revealed something far stranger and much more chaotic. The invisible mass at the center was not concentrated in a tiny single point as a single black hole would be. It was spread out over a region that spanned a fraction of a light year across. The stars were not orbiting one central king, but were swerving around a dense swarm of invisible objects scattered throughout the core. The calculations proved that the mystery mass was made up of dozens of small black holes orbiting each other in a frantic dance. This was a major shock to the scientific community because nobody expected a cluster to host a crowded, dark swarm. Instead of a single monster taking control, dozens of stellar mass black holes had gathered together at the very bottom of the cluster's gravity well. As these small black holes sank to the center, they kicked out lighter, normal stars and took over the core entirely. The middle of the cluster had turned into a hidden graveyard of dead stars, all fighting for gravitational dominance. This gap between a single black hole and a dark swarm changed our fundamental understanding of star cluster evolution. It turns out that when a star cluster core collapses, it creates an efficient factory for producing black hole collisions. In such a tightly packed swarm, black holes frequently pass close to one another, forming binary pairs. As these black hole pairs orbit each other, they ripple the fabric of space and time with gravitational waves. These waves carry energy away from the pair, causing them to spiral closer and closer together over millions of years. Eventually, the two black holes smash together in a violent merger, creating a larger black hole and releasing immense energy. What do you think happens when two black holes merge inside a crowded cluster of stars? Leave a comment below with your guess, and don't forget to like the video if you find these cosmic collisions as fascinating as I do. Your interactions help more people discover these incredible secrets of the universe. To track down these dark swarms, scientists had to look beyond visible light and use different types of astronomy. Visible light telescopes can only see the bright stars that are still burning nuclear fuel in their cores. They cannot directly see black holes or neutron stars because these dead objects release almost no visible light. So researchers turned to high-energy observatories like NASA's Chandra X-ray Observatory and ground-based radio telescopes. When a black hole in the dark swarm gets close to a normal star, its intense gravity strips gas away from that star. This stolen gas swirls around the black hole in a glowing disk, getting superheated to millions of degrees. As the gas gets superheated, it releases powerful bursts of X-rays that stream out into the darkness of space. By detecting these bright X-ray spots, astronomers can count how many active black hole pairs are hiding inside the collapsed core. The Chandra data confirmed that the core of the collapsed cluster was lit up with X-ray emissions from dozens of interacting pairs. This provided undeniable proof that the center was not empty space, but a hyperactive zone of dead star interactions. The numbers matched the gravitational measurements, confirming the presence of a dense black hole swarm. Here's a detail that researchers found particularly mind-blowing when analyzing the data. When two black holes merge, the resulting explosion of gravitational waves is often slightly uneven. This uneven blast of energy acts like a rocket thruster, giving the newly formed black hole a massive kinetic kick. If the kick speed is faster than the cluster's escape velocity, the black hole gets blasted completely out of the cluster into deep space. Escape velocity is the speed an object needs to break free from the gravitational pull of a larger body. For most star clusters, the escape velocity is around 50 kilometers per second, which is extremely fast. If the merger kick gives the new black hole a speed of 60 kilometers per second, it escapes forever. It leaves its home cluster behind and drifts alone through the empty space between galaxies as a rogue black hole. Scientists calculate that over billions of years, collapsed star clusters have shot thousands of rogue black holes into our galaxy. This means that our Milky Way is filled with invisible, fast-moving black holes that were born in the chaotic centers of collapsed clusters. They drift silently through space, completely invisible unless they happen to pass in front of a distant star. Right now, scientists are actively scanning the sky to track down these stripped stellar streams and wandering remnants. Using the Gaia satellite, astronomers have discovered long trails of stars stretching across tens of thousands of light years. These structures are called stellar streams, and they are the stretched-out corpses of star clusters that underwent core collapse. When a cluster's core collapses and gets filled with a black hole swarm, the entire structure becomes gravitationally fragile. As the cluster orbits through the Milky Way, the gravitational tidal forces of our galaxy pull on the cluster's outer edges. The light stars that were kicked out during core collapse are easily stripped away by the galaxy's pull. Instead of staying in a neat round sphere, the cluster gets pulled apart into a long river of stars flowing through space. One famous example is the Palomar 5 stellar stream, which stretches over 30,000 light-years across the sky. Palomar 5 is an ancient star cluster that is currently in the final stages of complete destruction. Astronomers found that Palomar 5 has roughly 3 times more black holes than expected for a cluster of its size. More than 20% of the total mass of Palomar 5 is made up entirely of black holes hiding in its core. This discovery showed that as a star cluster collapses and dissolves, the normal stars get stripped away first. The heavy black holes stay grouped together in the center until the very end of the cluster's life. Eventually, the normal stars are all gone, leaving behind a dark, invisible cluster made almost entirely of black holes. This was a massive revelation because it meant that many invisible structures might be orbiting our galaxy right now without us seeing them. We only see the glowing trails of stars that were ripped away during the collapse process. Could one of these invisible streams of dead stars or stray black holes be passing near our solar system in the distant future? Let me know what you think in the comments section below, and if you have not subscribed yet, take a second to hit that subscribe button right now. Joining the channel ensures you never miss an update on the dynamic and dangerous events shaping our cosmos. Now shift your focus from what happened billions of years ago to what is happening right this very second. In galaxies all across the observable universe, star clusters are reaching their critical core collapse threshold right now. Core collapse is not an event that happens and then instantly finishes like a dynamite explosion. It is an ongoing dynamic struggle between gravity and thermodynamics that lasts for hundreds of millions of years. As you listen to these words, millions of stars and distant clusters are swinging around dense black hole cores at extreme velocities. Scientists have realized that core collapse can actually reverse itself in a cycle known as core oscillations. When the core gets extremely tight, binary black holes and binary stars form very rapidly in the center. These binary systems release immense amounts of gravitational energy during close encounters with single stars. That sudden release of energy acts like a nuclear furnace, heating up the core and causing it to expand again. The core expands, the density drops, and the cluster takes a deep cosmic breath as the collapse pauses. But as the binary systems get kicked out or destroyed, the core cools down once more and gravity takes over again. This creates an endless cycle where the core contracts, heats up, expands, cools down, and contracts again over billions of years. It is like a beating heart made of millions of stars, pulsing slowly across cosmic time. Astronomers are using computer supercomputers to simulate millions of years of star movement in just a few days. These simulations show that a single cluster can go through multiple core collapse events during its long lifetime. Each cycle alters the cluster's structure, throwing out thousands of stars and altering the orbits of those that remain. This ongoing process has direct consequences for our understanding of how galaxies like the Milky Way grew and evolved. Globular clusters are the building blocks of galaxies. When early galaxies formed, they were filled with thousands of these dense clusters. Over billions of years, hundreds of star clusters collapsed, broke apart, and spilled their stars into the galactic halo. In fact, a large percentage of the old stars you see in the night sky were not born in the main galactic disk. They were born inside hyperdense star clusters that underwent core collapse and were torn apart by galactic tidal forces. Our own night sky is literally painted with the debris of ancient collapsed star clusters that died long ago. Understanding core collapse also helps scientists solve the mystery of fast radio bursts and powerful space radiation. When neutron stars and black holes are crammed together in a collapsed core, they frequently collide or merge. These high-energy collisions release incredible bursts of gamma rays, X-rays, and radio waves that travel across billions of light years. When we detect a mysterious flash of radio waves coming from a distant galaxy, it may be the signal of two dead stars colliding inside a collapsed core. By studying collapsed clusters, we are unlocking the engines that produce the most violent energy events in the universe. Zooming out to the bigger picture, this discovery reminds us that the universe is far more dynamic than it appears to human eyes. When we look up at the night sky, the stars seem fixed, permanent, and unchanging, like diamond studs on a black canvas. Human lives last for decades, while the life cycle of a star cluster spans tens of billions of years. Because our lives are so short, we mistake the slow movement of space for total stillness and safety. In reality, the universe is a constantly churning ocean of gravity, where entire cities of stars collapse, dissolve, and transform. Every star cluster we observe is on a journey toward its own inevitable gravitational evolution. Some will slowly evaporate as their stars drift away to the galactic vacuum over endless eons. Others will suffer core collapse, concentrating their mass into terrifying dark swarms of black holes and dead stellar remnants. These collapsed cores will continue to orbit their host galaxies, invisible sentinels carrying the heavy remains of ancient star generations. Studying them gives us a window into the ultimate fate of complex gravitational systems throughout time and space. It also gives us a profound perspective on our own place in the cosmic story. Our sun is a solitary star, orbiting peacefully in a quiet, low-density neighborhood of the Milky Way galaxy. We are fortunate not to live inside a collapsed star cluster core, where chaotic gravity and intense radiation would make life impossible. If Earth were situated inside a collapsed core, frequent close passes by neighboring stars would strip our planet from its orbit. Violent radiation from nearby black hole accretion disks would strip away our atmosphere, leaving behind a barren rock. The calm stability that allowed human life to emerge and thrive on Earth is a rare gift provided by our quiet location. Yet, despite our peaceful isolation, human curiosity allows us to look across millions of light years and decipher these extreme environments. We can use mathematics, physics, and advanced telescopes to peer into the hearts of collapsed clusters and understand their hidden laws. We can trace the invisible paths of dark black hole swarms and map out the ancient stellar rivers flowing around our galaxy. This scientific journey shows the amazing power of human intelligence to unlock the deep secrets of the universe from our small planet. Scientists are now preparing to launch next-generation space observatories that will study collapsed clusters in even greater detail. The Nancy Grace Roman Space Telescope and the Vera C. Rubin Observatory will scan the skies with unprecedented speed and sensitivity. They will discover thousands of new stellar streams and track the exact motions of stars inside hundreds of distant clusters. These tools will allow us to catch core collapse events as they happen across distant galaxies, revealing new physics we cannot yet predict. The story of collapsed star clusters is far from over, and the coming years will bring even more groundbreaking discoveries. To wrap up this incredible journey, let us look at what this all means for the future of astronomy and space exploration. Every telescope image we capture of these collapsed clusters brings us one step closer to understanding the grand architecture of space. Scientists are combining gravitational wave detections with optical observations to build a complete real-time map of black hole interactions. This new field of multi-messenger astronomy is opening doors that were completely closed to previous generations of skywatchers. We are no longer just looking at light, but actually listening to the vibrations of the cosmos itself. As these advanced telescopes come online, they will map every star cluster in our galaxy with extreme precision. We will be able to predict exactly which clusters are about to collapse next and which ones are dissolving into dark streams. This wealth of new data will challenge our theoretical models and force us to continuously adapt our understanding of gravity. Space continues to prove that it is far more complex, wild, and awe-inspiring than anything we could invent in science fiction. The secrets locked inside collapsed star clusters are just the beginning of what lies waiting to be uncovered in the dark. If you found this deep exploration of collapsed star clusters and black hole swarms fascinating, please hit that subscribe button right now. Make sure to turn on all notifications so you never miss another episode where we uncover the deepest mysteries of space. I would love to hear your thoughts on today's story, so drop a comment below answering this question. Do you think our galaxy is home to thousands of undiscovered dark swarms? Share this video with your friends, family, or anyone you know who loves space, science, and the mind-blowing reality of our universe. Thank you so much for watching, and stay curious as we continue exploring the cosmos together.